the Monongahela River does not forget. It moves the same way it moved in the summer of 1892, dark, wide, indifferent, carrying the reflections of furnace light on its surface like something the water swallowed and cannot release. Stand on the southern bank of that river at night, close your eyes, and you can still feel it. The vibration beneath your feet, the low industrial thunder that never fully stopped, the heat that pressed against the skin of every man who walked through the mill gates and surrendered himself to what waited inside. The Carnegie Steel Company's Homestead Works was not merely a factory. It was a city built for destruction. The destruction of raw ore, of pig iron, of limestone and coke, and every natural thing that could be fed into its furnaces and returned as something harder, sharper, more useful to an expanding nation. At its peak, the complex stretched for half a mile along the river's edge. Its open hearth furnaces burned at temperatures exceeding 3,000 degrees Fahrenheit. Its converting vessels processed hundreds of tons of liquid steel every single day. And inside its walls, men worked 12-hour shifts, 6 days a week, in conditions that modern occupational science would classify without hesitation as catastrophic. Between 1880 and 1910, the American steel industry killed or permanently disabled more workers per year than any other industrial sector in the developed world. Homestead was not an exception to that record. Homestead was its center. But the deaths at Homestead were not simply accidents. They were not the random misfortunes of a dangerous trade. They were the predictable, measurable, economically tolerated consequences of a system designed, consciously and deliberately, to extract maximum production from human bodies at minimum cost for as long as those bodies could endure. This is not a story about fire, though there will be fire. This is not a story about a single disaster, though there will be disaster. This is a story about the hidden mathematics of industrial capitalism, the calculation that placed a price on a man's survival, found that price acceptable, and built one of the most productive steel mills in human history on top of it. The river still moves, the mill is mostly gone, but the question has not disappeared. Why did they die? There is a number that haunts the history of American steel, and it is not the tonnage produced, nor the miles of rail laid across a continent, nor the height of the buildings that rose from the metal poured at Homestead and mills like it. The number is this. In the single decade between 1880 and 1890, the American steel industry's output increased by more than 400%. And in that same decade, the rate of workplace fatalities did not decline, it rose. This is the central paradox of Homestead. The more efficiently the mill produced, the more dangerous it became to work inside it. Progress and death were not opposites in this system, they were partners. Andrew Carnegie understood steel the way a general understands a campaign, not as a craft, but as a contest of scale. Every efficiency gained on the production floor meant a reduction in cost per ton. Every reduction in cost per ton meant a wider margin against competitors. And every margin gained meant more capital to reinvest, more furnaces built, more men hired, more tons processed. The logic was circular, self-reinforcing, and absolute. Within that logic, the human body was one variable among many. It was cheaper to replace a worker than to redesign the process that was destroying him. This was not cruelty in the personal sense. Carnegie did not hate his workers. Several of his contemporaries recorded him as a man capable of genuine sentiment, of speeches about the dignity of labor, of written commitments to the idea that the man who worked with his hands deserved a fair share of what his hands produced. He wrote those words. He meant them in the abstract, and then he returned to his offices in Pittsburgh and New York and approved the policies that made those words meaningless on the floor of the Homestead Works. The paradox deepens when examined against the backdrop of wealth generated. In 1892, the year that would become Homestead's most infamous, Carnegie Steel reported profits of approximately $4 million. Andrew Carnegie's personal share of those profits was roughly $2.5 million in a single year, at a time when the average Homestead steelworker earned between $450 and $600 annually. The men who fed the furnaces, who poured the heats, who guided 300-ton ladles of liquid steel through the converting bays, earned in a lifetime what their employer earned in a matter of weeks. But profit margins alone do not explain the deaths. The deeper mechanism was speed. The relentless acceleration of production timelines compressed every margin of safety that experience and instinct had built into the older rhythms of the trade. Veterans of the mill, men who had worked open hearth furnaces for a decade or more, knew intuitively when a heat was not ready, when a ladle was stressed, when the temperature of a mold had not equalized sufficiently to receive a pour. That knowledge lived in the body, in the eyes, in the particular quality of silence a piece of equipment made before it failed. But as production quotas climbed, as supervisors pressed for faster cycle times, as the economic logic of the mill demanded more tonnage from the same number of hours, that knowledge was systematically overridden. Men were pushed past the point where their experience could protect them, and they died in the space between what they knew and what they were ordered to do. This is the paradox that Homestead represents in the history of American industry. Not the story of ignorance, but the story of knowledge, specific, technical, human knowledge, sacrificed deliberately on the altar of production. The river received what the mill discarded, and the mill discarded men. To understand why Homestead was built the way it was built, and why it operated the way it operated, it is necessary to understand what America needed in the decades following the Civil War, and how completely, how desperately, how structurally it needed steel. The United States in 1865 was a nation whose infrastructure had been built almost entirely from wood and wrought iron. Its railroad network, already the largest in the world by certain measures, ran on iron rails that wore out within 2 to 3 years of heavy use. Its bridges were wooden trestles or cast iron constructions of limited span and questionable load tolerance. Its urban buildings rose no higher than 6 or 7 stories before the weight of masonry construction made further elevation structurally impractical. The nation was, in engineering terms, at the edge of what its existing materials could support. Steel changed every one of those limitations simultaneously. A steel rail lasted 10 times longer than an iron rail under equivalent traffic loads. A steel bridge could span distances and carry weights that no iron or wooden structure could approach. Steel-framed buildings, using the skeletal construction methods pioneered in Chicago in the 1880s, could rise to heights that would have been structurally impossible a decade earlier. Steel transformed not just what America could build, but how fast it could build, how far it could reach, and how confidently it could project economic and military power across a continent and eventually an ocean. Between 1870 and 1900, American railroad construction alone consumed tens of millions of tons of steel rail. The transcontinental network expanded from roughly 53,000 miles of track in 1870 to more than 193,000 miles by 1900. Every mile of that expansion required steel. Every bridge crossing every river on that network required steel. Every locomotive, every freight car, every station infrastructure required steel. The appetite was not metaphorical. It was a physical, measurable, relentless demand that ran ahead of industrial capacity for the entire last quarter of the 19th century. Carnegie recognized this demand early, and positioned himself to capture it with a precision that his contemporaries found almost unsettling. When he built the Edgar Thomson Steel Works in Braddock, Pennsylvania in 1875, the direct predecessor to the expanded Homestead complex. He did not build it to meet current demand. He built it to create demand, to drive down the price of steel rail so aggressively that competitors either adopted his methods or collapsed. He brought in Captain William Jones, the most gifted production engineer of his generation, and gave him a simple directive: make it faster, make it cheaper, make it more than anyone else can make. Jones delivered. By 1880, the Edgar Thomson Works was producing steel rail at a cost that undercut every competitor in the American market. And Carnegie used every dollar of profit to build more capacity, acquire more mills, integrate backward into ore and coke production, and forward into finishing and fabrication. The Homestead Works, acquired by Carnegie in 1883 from a group of Pittsburgh businessmen who had built it, but could not operate it profitably, became the centerpiece of this empire. It was retooled, expanded, and redirected from rail production toward structural steel and armor plate, the two products whose demand would define the final decade of the 19th century. Structural steel for the buildings and bridges of an urbanizing nation. Armor plate for the warships of a nation beginning to imagine itself as a naval power. These were not small markets. The United States Navy's modernization program, launched in the late 1880s, required armor plate of a quality and quantity that only a handful of mills in the world could produce. Homestead was designated as one of two primary domestic suppliers. The contracts were enormous. The technical requirements were extreme, and the pressure those contracts placed on the production system at Homestead, on its furnaces, its rolling mills, its workforce, and its safety margins, was immense and unrelenting. A nation building itself from steel required a mill that never stopped, and a mill that never stopped required men who never rested. The historical context is not background to the story of Homestead's dead, it is the explanation for them. The Homestead Works did not emerge fully formed. It grew organically, voraciously, with the particular logic of industrial organisms that expand in proportion to the energy available to feed them. Between 1883, when Carnegie acquired the mill, and 1892, when it became the site of the most dramatic labor confrontation in American history, the Homestead complex tripled in physical size, quadrupled in productive capacity, and transformed from a moderately successful regional mill into one of the most technically advanced steel production facilities on Earth. To understand what that transformation meant in human terms, it is necessary to understand what the mill actually was, not as an abstraction, but as a physical place, a specific arrangement of buildings and machines and fire and men that covered 600 acres along the south bank of the Monongahela River, 12 miles upstream from Pittsburgh. Enter through the main gate on 8th Avenue in the summer of 1890. The first thing that reaches you is not sight but sound, a layered industrial roar composed of a dozen distinct frequencies, from the deep concussive rhythm of the steam hammers to the high metallic scream of the plate mill saws cutting finished steel to specification. Beneath those sounds, always, the low, continuous vibration of the blowing engines feeding air to the furnaces, a pulse so constant that workers ceased to hear it as sound and felt it instead as a property of the air itself. The open hearth furnace building was the mill's centerpiece, a structure 500 feet long and 150 feet wide, housing a row of furnaces that operated continuously, day and night, 365 days a year. Each furnace held a charge of 50 tons of molten metal, heated by regenerative gas burners to temperatures at which steel became liquid, fluid, brilliant, and almost unimaginably dangerous. The process of tapping a heat, of releasing that liquid metal into a ladle and transferring it to the casting floor, required a choreography of human action and mechanical movement that left almost no margin for error and none whatsoever for hesitation. The Bessemer converters, 5 of them by 1890, operated on a different principle and a different time scale. Where the open hearth process took hours, the Bessemer process took minutes. Air was blown through molten pig iron under pressure, burning off carbon and impurities in a spectacular display of fire and sparks that lit the interior of the converter building like a continuous electrical storm. The entire process, from charged to finished steel, took less than 20 minutes. It was the fastest steelmaking process in the world. It was also, by considerable measure, the most violent. The rolling mills took the steel that the furnaces produced and transformed it into usable form, into structural beams, into armor plate, into the rails and rods and bars that the nation's appetite demanded. The plate mill, which processed the armor steel for naval contracts, contained rolling equipment of a scale that was almost architectural. Rolling stands 15 feet in diameter, drive shafts 8 inches thick. The force required to reduce a 300-ton ingot of steel to a finished plate of specified thickness was measured not in tons, but in thousands of tons per square inch, applied through machinery that operated at speeds and loads that pushed contemporary engineering to its absolute limits. Carnegie hired the best engineers available to build and maintain this system. He paid them extraordinarily well by the standards of the time. He gave them broad authority over technical decisions and held them to performance standards that were precise, demanding, and non-negotiable. Captain William Jones, before his death in a furnace explosion at Braddock in 1889, had established a culture of technical excellence at Carnegie's mills that outlasted him. His successor at Homestead, Charles Schwab, later to become one of the most powerful figures in American steel, inherited that culture and refined it further. But technical excellence, in the context of Carnegie's mills, was always excellence in the service of production volume. The engineering genius of Homestead was inseparable from its production imperative. Every improvement in furnace design, every refinement in rolling mill configuration, every advancement in metallurgical practice was evaluated first and primarily by its effect on tons produced per hour. Safety was not irrelevant to this calculation. A catastrophic failure that destroyed equipment and killed large numbers of men was economically costly as well as humanly devastating. But smaller, routine dangers, the kind that killed one man at a time, are the kind that disabled workers gradually through cumulative exposure to heat and noise and toxic atmosphere. These were factored into the cost of production and accepted as inherent to the process. This was Carnegie's kingdom. Brilliant, productive, technically magnificent, and built on a foundation of human endurance that had a precise and calculable limit. To die at Homestead, a man did not need to make a mistake. That is the fact that distinguishes the Homestead Works from the popular mythology of industrial accidents, the mythology that attributes every death to carelessness, to inattention, to the failure of an individual to respect the power of the machines around him. The mythology is comforting because it assigns blame to the victim and absolves the system. At Homestead, the system itself was the instrument of death. The machines were not dangerous because men failed to respect them. The machines were dangerous because they had been designed, configured, and operated at parameters that made periodic catastrophe a mathematical certainty. Begin with heat. The open hearth furnaces at Homestead operated at sustained temperatures between 2,800 and 3,200 degrees Fahrenheit. At these temperatures, radiant heat alone, without direct contact, without any mechanical failure, was capable of causing severe burns at distances of 15 feet from an open furnace door. Workers on the charging floor, whose job was to introduce raw materials into the furnace through its front doors, were exposed to this radiant heat for hours at a time. There was no effective shielding technology available in the 1880s and 1890s that could be practically deployed in a working furnace bay. Men wore heavy canvas clothing impregnated with alum solution, a treatment that offered partial protection against brief exposures. It offered nothing against sustained radiant heat over a 12-hour shift. The physiological consequences accumulated invisibly. Chronic dehydration was universal among furnace workers. In a single shift, a man working the charging floor could lose 8 to 10 pounds of body weight through perspiration, weight that could only be partially replaced by the water available at the mill, which was frequently contaminated with iron, particulate, and runoff from the coke yards. Heat exhaustion was not an emergency at Homestead. It was a chronic condition, managed by men who had no choice but to manage it, whose bodies had adapted over years of exposure to a baseline level of physiological stress that would have incapacitated an unaccustomed person within hours. Beyond heat, the atmosphere inside the mill was chemically hostile in ways that were not fully understood even by the most technically sophisticated managers of the era. The coking process, which converted raw coal into the coke used as fuel in the furnaces, released benzene, toluene, naphthalene, and a range of polycyclic aromatic hydrocarbons into the air of the coke yards and adjacent production areas. These compounds were carcinogenic, a fact that industrial medicine would not definitively establish until decades later, but whose effects were visible in the elevated rates of respiratory disease and certain cancers among long-term coke workers even in the 1890s. Men coughed. Men developed chronic bronchitis within their first years at the mill. Men retired, those who survived long enough to retire, with lung capacities so reduced that climbing a flight of stairs left them breathless. The mechanical hazards were more immediate and more dramatic, but in terms of cumulative mortality they were arguably less significant than the atmospheric ones. The catastrophic failures, the furnace explosions, the ladle ruptures, the rolling mill accidents, killed men suddenly and visibly. They generated coroner's inquiries, newspaper coverage, and the kind of institutional attention that slower deaths never attracted. A worker who died in a furnace explosion was a tragedy. A worker who died of chronic lung disease 15 years after leaving the mill was a statistic that the mill's accounting never recorded. The ladle system deserves particular examination. The transfer of liquid steel from furnace tap to casting floor was accomplished by means of large refractory-lined steel vessels, ladles, suspended from overhead cranes and capable of holding between 50 and 150 tons of metal at temperatures exceeding 2,900 degrees Fahrenheit. These ladles were the most dangerous single piece of equipment in the mill. Their refractory linings, the ceramic material that prevented the liquid steel from burning through the steel shell of the vessel, degraded with each heat they processed. A new lining was rated for a certain number of heats before mandatory replacement. Under normal operating conditions, that replacement schedule was adhered to. Under production pressure, it was not. A ladle whose lining had thinned beyond safe tolerance did not fail dramatically or immediately. It failed gradually in a process called a breakout, a slow penetration of liquid steel through the refractory, which might manifest first as a small leak, a thin stream of brilliant metal running down the outside of the ladle shell. A breakout in progress gave a few seconds of warning before it became catastrophic. A full ladle rupture, the sudden failure of a lining that had thinned to the point of structural collapse, gave no warning at all. 150 tons of liquid steel at 2,900 degrees Fahrenheit, released instantaneously into a working bay filled with men, water, equipment, and combustible material, produced a disaster of a specific and terrible character that experienced millmen described in terms that do not translate well into clinical language. The crane system that moved these ladles was itself a source of continuous hazard. Overhead, cranes operated in the same airspace as the men working below them. Dropped loads, crane collisions, and cable failures were recorded with grim regularity in the mill's accident logs. The logs themselves are instructive. They list, in the spare administrative language of the era, deaths and injuries of a frequency and variety that reads less like an accident record and more like a taxonomy of the ways industrial machinery can destroy a human body. Crushings, burns, falls from elevation, asphyxiation in confined spaces, electrocution as electrical systems expanded through the mill in the late 1880s, lacerations from broken cables and shattered tooling. The logs record these events without commentary, without causal analysis, and without any notation, suggesting that the frequency of their occurrence was considered anomalous or requiring of systematic response. This was the engineering reality of Homestead, a system of extraordinary technical sophistication operating at the boundary of what its materials and its men could sustain, pushed continuously toward that boundary by the economic logic that had built it. Every industrial system has tolerances, the margins between designed operating parameters and the point at which components fail. In well-managed systems, those tolerances are wide, conservatively established, and rigorously maintained. At Homestead, the tolerances were narrow by design, eroded by practice, and defended by an accounting logic that treated the cost of a human life as a line item rather than a limit. The hidden flaw in the Homestead system was not a single engineering deficiency that could be identified, corrected, and eliminated. It was structural, embedded in the relationship between production targets, labor costs, maintenance schedules, and the human capacity for endurance. It operated at every level of the organization simultaneously, from the decisions made in Carnegie's offices in New York to the choices made by individual foremen on the production floor at 3 a.m. Consider the 12-hour shift. By the standards of contemporary industrial practice, a 12-hour shift was not exceptional. Many American industries operated on similar schedules in the 1880s and 1890s. But the 12-hour shift at a steel mill was categorically different from a 12-hour shift in a textile factory or a machine shop. The physical demands of steel work, the heat, the weight of the tools, the sustained muscular effort required to manage furnace operations and rolling mill equipment, created a fatigue profile that accumulated not just within a single shift, but across successive shifts, across weeks and months of continuous exposure. The most dangerous moment in a steelworker's shift was not the first hour, when the man was fresh and alert and his reflexes were at their sharpest. The most dangerous moment was the final 2 hours, when fatigue had compressed his reaction time, narrowed his attention, and degraded the fine motor control that the handling of molten metal required. Mill accident records, analyzed by the small number of industrial physicians who began studying occupational safety in the 1890s, showed a consistent and pronounced spike in serious accidents in the 10th, 11th, and 12th hours of a shift. The men who died in those hours died in part because they were exhausted by a schedule that the mill's management knew was physiologically unsustainable and maintained regardless. There was also the question of the swing shift, the transition that occurred every 2 weeks when day workers rotated to night duty and night workers rotated to day. This transition required workers to complete a single shift of 24 hours, continuous duration. A full day shift followed immediately by a full night shift without intervening rest. This practice, known in the industry as the long turn, was universal at Carnegie's mills. Its effects on human physiology were severe. Sleep deprivation of this magnitude produced cognitive impairment equivalent, by modern measurement, to significant alcohol intoxication. Men operating heavy equipment, managing molten metal, making rapid decisions in environments where a wrong choice could be immediately fatal. These men were doing so in a state of neurological compromise that their employers understood, tolerated, and scheduled into the production calendar as a routine administrative matter. The maintenance system compounded every other hazard. Equipment at Homestead ran continuously. The economic logic of the mill made scheduled downtime for maintenance and inspection an expensive inconvenience. Every hour a furnace was cold was an hour of production lost, a cost that appeared directly and visibly in the mill's accounts. The cost of running equipment past its service limits appeared differently, diffusely eventually, in the form of failures that were recorded as accidents rather than as the predictable consequences of deferred maintenance. Refractory linings were pushed beyond rated service lives. Crane cables were inspected on schedules that lagged behind actual wear rates. Steam lines and pressure vessels accumulated fatigue that visual inspection, the primary maintenance tool of the era, could not reliably detect. The mill employed skilled mechanics and maintenance engineers whose professional judgment consistently identified equipment operating outside safe parameters. Their reports entered the administrative record. The record shows with uncomfortable clarity that those reports were frequently acknowledged and infrequently acted upon when action would have required production interruption. The foreman system created a final, human layer of structural danger. Foremen at Homestead were responsible simultaneously for production output and workforce safety, a combination of accountabilities that created an irresolvable conflict of interest. A foreman whose crew failed to meet production targets faced direct economic consequences. A foreman whose crew suffered an accident faced paperwork, inquiry, and the temporary disruption of his operation. The incentive structure consistently rewarded production over caution. Foremen who pushed their crews hardest, who ran equipment longest between maintenance cycles, who demanded the fastest possible pace from men already operating at the edge of physical capacity. These foremen were the ones who produced the tonnage that the mill's accounts celebrated. The hidden flaw was not hidden at all, to anyone who looked at it directly. It was the designed tolerance of the system, the calculated acceptance that a certain number of men would die so that a certain number of tons could be produced. The calculation was never written down in those terms. It did not need to be. It was embedded in every schedule, every maintenance deferral, every production target that exceeded what human physiology could safely sustain. His name was likely Slavic, Petrovich Kowalczyk Novak, one of the thousands of Eastern European immigrants who had come to Homestead in the 1880s, drawn by wages that, while brutal by any humane standard, exceeded what was available to them in the collapsing agricultural economies of Slovakia, Poland, Hungary, and Croatia. He would have arrived by train, carrying everything he owned in a single bag, speaking little or no English, directed by a labor agent to a boarding house on one of Homestead's narrow hillside streets, where 8 or 10 men from his home region shared 2 rooms and a cooking stove. He would have been hired within days of arrival. The mill always needed men, not skilled men. Skilled men were relatively few, relatively well compensated, and the object of considerable organizational effort by the Amalgamated Association of Iron and Steel Workers, the union that represented the craft workers at Homestead. The mill needed unskilled men. Men to move materials, to operate the less technically demanding functions of the furnace and rolling mill operations, to do the physical labor that the machine system required but had not yet replaced. These men were hired without ceremony, assigned to a crew, and put to work with a minimum of instruction and essentially no formal safety training. Follow him through a single shift. He reports at 6 in the morning, the day turn, at the gate on 8th Avenue, joins the stream of several hundred men moving through the entrance, and walks to the open hearth building where his crew foreman assigns him to the charging floor. His job today is what it is every day, shoveling limestone and ore additions into the furnace, charging buckets, moving material from the stockpiles on the charging floor to the machinery that introduces it into the furnace. It is heavy work. The charging floor is the hottest accessible point in the furnace building, the point closest to the furnace doors, the point where radiant heat is most concentrated. By 7 in the morning, he has already sweated through his clothing. The temperature on the charging floor, measured on the rare occasions when anyone measured it, routinely exceeded 120 degrees Fahrenheit in the summer months and rarely fell below 100 degrees even in winter. He drinks water from a shared pail, the same water, drawn from the same source used by every man on the crew. The water is warm, it tastes of iron. The furnace he works beside holds a heat that has been building since midnight. 50 tons of steel, now approaching the temperature at which it will be tapped, released through the furnace's tap hole into the waiting ladle below. The tap is a critical moment, requiring the coordinated effort of the tap hole crew, the crane operator, and the casting floor team simultaneously. When the tap hole opens, liquid steel at 2,950 degrees Fahrenheit flows in a brilliant, roaring stream into the ladle, generating a plume of radiant heat and sparks that forces every man in the immediate vicinity to shield his face and retreat to the limit of what his job allows. There is no retreating beyond that limit. The work continues regardless of what the heat demands of the body performing it. At noon he eats. The meal is brought to him: bread, salt pork, occasionally beans, because leaving the building for the 30-minute meal break and returning would consume the break entirely. He eats on the charging floor, 15 feet from a furnace operating at full temperature, in the heat and noise and particulate atmosphere that constitutes his working environment. The food tastes of sulfur from the coke gas that permeates the building. He has stopped noticing. The afternoon brings the most dangerous hours. The heat has peaked. The crew has been working for 8 hours. A second heat is ready for tapping. The crane operator, a skilled man, relatively well paid with years of experience, is on his second consecutive shift because his relief called sick and no replacement was available. His movements are slightly slower than usual, his attention fractionally narrowed by fatigue. No one on the floor would say he is unfit to operate his crane. No one on the floor would say he is entirely fit. The tap proceeds. The ladle fills. The crane begins its movement across the bay toward the casting floor. And then, on this particular afternoon, on this particular shift, in this particular bay, nothing happens. The crane completes its movement. The steel is poured. The heat is recorded. The foreman marks his production log. The shift continues. But on another afternoon, one that comes as surely as the calendar advances, as predictably as the degradation of refractory linings and the accumulation of human fatigue, the movement is not completed. A cable, worn past its rated tension limit on a maintenance schedule that ran 3 weeks late, parts under the load of the full ladle. Or the crane operator, his reaction time compressed by exhaustion, misreads the position of a support column in the bay's dim interior. Or the ladle itself, its lining thinned beyond tolerance by 2 additional heats run past the replacement schedule, begins to leak as it moves overhead. In any of these cases, and all of them occurred, at Homestead and at mills throughout the Carnegie system, with a frequency documented in accident logs that Carnegie's management reviewed and filed, the man on the charging floor below has no warning and no recourse. He is where his job requires him to be. He is doing what he was hired to do. And the system that placed him there, in that position, at that moment, bears the full weight of what happens next. At 6 in the evening, if he is still alive, his shift ends. He walks out through the gate on 8th Avenue, back into the ordinary air of a Pennsylvania summer evening. He is too tired to eat immediately. He sits on the steps of his boarding house while the furnace glow in the sky above the mill pulses orange and red against the clouds. Tomorrow he will do it again. And the day after that, and the day after that, until the mill no longer needs him, or until the mill finishes him. This was the life inside Homestead. Not exceptional, not unusual. The daily reality of several thousand men, repeated across every shift, across every week of every year that the mill operated. The men of Homestead had endured the heat, the hours, the chemical atmosphere, and the casual proximity of death for years before the summer of 1892 forced the fundamental question into the open. The question was not new. It had been present in every decision Carnegie's management had made about wages, schedules, and working conditions since the mill's acquisition in 1883. But in the summer of 1892, it became impossible to defer, impossible to manage through the incremental adjustments and selective concessions that had kept the mill's labor relations from open rupture for nearly a decade. The immediate trigger was a wage contract. The Amalgamated Association of Iron and Steel Workers, the union representing the skilled workers at Homestead, the rollers, the heaters, the melters, whose craft knowledge made the mill's most technically demanding operations possible, had operated under a sliding scale contract that tied their wages to the market price of steel. As steel prices rose, wages rose with them. As Carnegie's production efficiencies drove steel prices downward through the late 1880s, wages fell accordingly. By 1892, the Amalgamated was facing a contract renewal that Carnegie's management, under the direct supervision of Chairman Henry Clay Frick, had structured as a fundamental challenge to the union's existence at Homestead. Frick's proposed contract contained three elements that the Amalgamated found unacceptable, individually and collectively catastrophic. The first was a significant reduction in the base wage rate on which the sliding scale operated. The second was a lowering of the ceiling price above which the sliding scale would no longer increase wages, effectively capping the workers' share of productivity gains at a level below what the previous contract had provided. The third, and most significant, was a deadline. If the contract was not signed by June 24, 1892, Carnegie Steel would cease to recognize the Amalgamated Association as the bargaining representative of Homestead's workers and would reopen the mill as a non-union operation. Carnegie was in Scotland when Frick delivered this ultimatum. His correspondence from that period, letters and cables exchanged with Frick across the Atlantic, has been analyzed extensively by labor historians and reveals a man engaged in deliberate self-distancing from the confrontation his own policies had engineered. Carnegie wrote to Frick expressing confidence, expressing support, and expressing, in terms that would become historically notorious, the view that the mill could be successfully operated without the union if necessary. He then remained in Scotland while Frick executed the strategy they had jointly designed. Frick moved with the systematic efficiency that characterized his management style. In late June, as the contract deadline approached and negotiations produced no agreement, he began construction of a 3-mile wooden fence around the perimeter of the Homestead Works. The fence was 12 feet high. It was topped with barbed wire. At regular intervals, it was pierced by rifle holes, apertures of a size and height that allowed a man standing inside the fence to fire outward while protected from return fire. The workers of Homestead, watching this structure rise around the mill where they worked, gave it a name immediately. They called it Fort Frick. The contract deadline passed without agreement. Frick locked out the workforce on June 28th and announced that the mill would reopen with replacement workers, strikebreakers in the language of the time, on July 6th. To protect the replacement workers and secure the mill against interference, he contracted with the Pinkerton National Detective Agency for the services of 300 armed agents. The Pinkertons were a private security force of considerable reputation and considerable notoriety. Their involvement in labor disputes throughout the 1880s had established them, in the era's understanding of organized labor across the country, as a mercenary army available to the highest industrial bidder. The 300 Pinkerton agents were transported from their staging points in Pittsburgh and Chicago by river barge. 2 steel barges, the Iron Mountain and the Monongahela, towed by a steam tug up the river toward Homestead in the early hours of July 6, 1892. The approach was intended to be covert, timed for the pre-dawn hours when the workers' picket lines would be thinnest. It was neither covert nor timed effectively. The Amalgamated's watch system along the river detected the barges while they were still miles downstream, and by the time the tug approached the Homestead landing at approximately 4 in the morning, several thousand workers and their family members had assembled on the riverbank. What followed was not the brief, decisive assertion of corporate authority that Frick had anticipated. It was a battle, disordered, violent, sustained across the entire length of the daylight hours of July 6, 1892, and ultimately unresolved by force. The Pinkerton agents attempted to land from the barges and were met with gunfire from the workers on the bank. The workers attempted to storm the barges and were met with gunfire from the Pinkertons within. Men died on both sides. The exact number has been debated by historians. Contemporary accounts vary in their tallies, but the most carefully researched figures indicate 7 workers killed and 3 Pinkerton agents dead, with dozens wounded on both sides, before the Pinkerton agents, trapped on their barges and unable to land, agreed to surrender at 5 in the afternoon. The surrender was not the end. When the Pinkerton agents walked off the barges under a guarantee of safe passage, the crowd that had gathered, which now included women and children, men who had not been part of the organized strike action, citizens of Homestead whose relationship to the mill was peripheral or entirely absent, fell upon them with a savagery that shocked even those sympathetic to the workers' cause. Men were beaten. Men were stripped of their weapons and their dignity simultaneously. The scene on the landing at Homestead on the afternoon of July 6th represented something that had broken loose from the controlled narrative of a labor dispute and become something older, rawer, and more difficult to categorize. Carnegie's management had anticipated resistance. They had not anticipated this, the complete seizure of the mill and its immediate surroundings by an organized workforce that proceeded to run the facility's non-production functions, maintain order within the town, and present to the arriving press and public the image of a community that had reclaimed its own industrial space by force. The reclamation lasted 9 days. On July 15th, Pennsylvania Governor Robert Pattison ordered 8,500 state militia troops to Homestead. They arrived without resistance. The workers, facing the organized military force of the state government rather than a private security contractor, chose not to fight. The militia secured the mill. Frick began the process of reopening with replacement workers. The Amalgamated Association, its position fatally weakened by the military occupation and the subsequent prosecution of its leaders on charges of murder and treason, charges that were ultimately dismissed but consumed the union's resources and leadership attention for months, watched its membership at Homestead dissolve, as workers either accepted the new non-union terms or were permanently replaced. On July 23, 1892, 17 days after the battle on the riverbank, a young anarchist named Alexander Berkman entered Henry Clay Frick's office in Pittsburgh and shot him twice at close range, then stabbed him 3 times before being subdued. Frick survived. Berkman served 14 years in prison. The assassination attempt, intended by Berkman as an act of revolutionary solidarity with the Homestead workers, achieved the precise opposite of its intended effect. It associated the strikers' cause with political violence in the public mind, eroded the considerable sympathy the workers had accumulated in the days following the battle, and provided Carnegie's management with a rhetorical weapon against the union that proved more durable than any legal charge. By November 1892, the strike was over. The Amalgamated Association had been effectively destroyed at Homestead. Carnegie Steel reopened the mill as a non-union facility and maintained that status for the next 4 decades. The wage scales that Frick had proposed, the scales the workers had struck to resist, were implemented in full. The men who had fought on the riverbank in July returned to the mill, or did not return to the mill. Those who returned found the work unchanged in its physical demands and its dangers, but fundamentally altered in its human dimensions. The informal systems of peer oversight, the accumulated craft knowledge that the skilled workers had used to moderate the pace of production and maintain practical safety margins, the collective power to refuse assignments that experienced men judged excessively dangerous, all of this was gone. In its place was the unmediated authority of management over every aspect of the production process and the conditions under which it was carried out. The mill became more productive after 1892. It also became more dangerous. The accident rate at Homestead in the years following the destruction of the Union rose measurably and consistently. The men who had died before 1892 had died within a system that contained, however imperfectly, some countervailing force against the worst excesses of production pressure. The men who died after 1892 died within a system from which that force had been deliberately and permanently removed. The defeat of the Amalgamated Association at Homestead in 1892 was not an isolated event in the history of American labor. It was a signal, received and acted upon by steel operators and industrial managers across the country with a speed and unanimity that confirmed how carefully it had been observed. Within 3 years of the Homestead lockout, the Amalgamated had been removed from every major Carnegie facility. Within a decade, union representation in the American steel industry had collapsed from a meaningful presence in the industry's most productive mills to a marginal force confined to smaller, older operations whose economic significance was declining year by year. The consequences for working conditions were immediate, measurable, and severe. Without collective bargaining, the 12-hour shift became permanent rather than contested. Prior to 1892, the Amalgamated had used its contract leverage to negotiate informal limitations on the most extreme scheduling practices: the long turn, the mandatory overtime, the forced double shifts that exhausted men beyond the point of safe functioning. These limitations were imperfect, inconsistently enforced, and frequently violated by production pressure. But they existed. After 1892, they did not exist. The 12-hour shift and the 24-hour long turn became simply the condition of employment at Homestead and throughout the Carnegie system, unchallengeable and uncontested. The wage structure changed in ways that compounded physical danger. The elimination of the sliding scale and its replacement with fixed day rates removed the financial incentive that had given skilled workers a measure of economic security proportional to their productivity. In its place, Carnegie's management instituted a system of individual piece rates and performance bonuses that tied individual workers' earnings directly to their personal production output. The effect was precisely what the incentive structure was designed to produce. Men pushed themselves harder, ran equipment faster, deferred rest breaks, and made decisions under time pressure that they would not have made with adequate time to assess risk. The bonus system made each worker his own most effective exploiter. The scale of injury and death in the years following 1892 is documented in sources that were not produced by the mill or its management. The Allegheny County Coroner's records, the records of the various charitable and mutual aid organizations that served Homestead's immigrant communities, and the pioneering surveys conducted by social investigator Crystal Eastman in her 1910 study Work Accidents and the Law, provide a statistical portrait of industrial mortality that the mill's own records systematically obscured. Eastman's survey of Allegheny County for the year 1906, the year she selected as her study period, identified 526 men killed in work accidents in the county's steel and iron industries in a single 12-month period. This figure represented only the deaths that could be definitively attributed to workplace accidents. It did not include deaths from occupational disease, the lung conditions, the cancers, the cardiovascular damage caused by years of heat stress, which were not categorized as work-related fatalities in the mortality records of the period. It did not include men who died of injuries sustained at work days or weeks after the accident that caused those injuries, whose death certificates attributed the cause of death to the medical condition rather than the industrial event, and it did not include the men who were disabled rather than killed, whose working lives ended at Homestead, but whose bodies continued to deteriorate for years afterward in the boarding houses and tenements of the mill district. The community of Homestead itself bore the concentrated weight of these consequences. The town that had grown up around the mill, the grid of narrow streets climbing the hillside above the river, the boarding houses and company-adjacent retail establishments and churches whose congregation lists read like a registry of Central European immigration, was a community shaped entirely by the mill's demands and entirely vulnerable to the mill's indifference. Widows were not uncommon in Homestead. They were a demographic category significant enough to warrant the specific attention of the charitable organizations that operated in the town. A woman whose husband was killed at the mill received no compensation from Carnegie Steel, no pension, no death benefit, no acknowledgement of economic responsibility. She received, if she was fortunate, a collection taken up by her husband's crew, and the assistance of the Ethnic Mutual Aid Society to which her husband had contributed during his working life. If she had children, she had the option of taking in boarders. Other mill workers, men who paid for a bed and meals in the cramped house that her husband's wages had rented but not owned. If her children were old enough, they could find work. At the mill. At the same mill. The ethnic geography of Homestead's mortality was not random. The most dangerous jobs in the mill, the unskilled and semi-skilled positions on the furnace floor, in the coke yards, in the material handling operations that exposed men most continuously to heat, chemical atmosphere, and the direct proximity of molten metal, were occupied overwhelmingly by the most recently arrived immigrant groups. In the 1880s, those groups were primarily Irish and German. By the 1890s and into the early 20th century, they were primarily Slavic, Slovak, Polish, Croatian, Hungarian, men whose limited English, unfamiliarity with American industrial culture, and economic desperation placed them in a position of minimal negotiating leverage relative to the mill's hiring system. These men died at higher rates than their more established colleagues not because they were less competent or less careful, but because they occupied the positions in the production system that the production system's logic had determined were expendable. The hierarchy of danger at Homestead mapped almost perfectly onto the hierarchy of economic and social vulnerability. The men with the least power to resist dangerous assignments were given the most dangerous assignments. This was not coincidental, it was structural. Carnegie himself withdrew further from the operational realities of his mills as their scale and productivity increased. By the mid-1890s, he spent the majority of his time at his Scottish estate, Skibo Castle, engaged in the philanthropic projects, libraries, concert halls, universities that would constitute his public legacy. The distance between Skibo Castle and the charging floor of the Homestead Open Hearth building was not merely geographical. It was the distance between the abstraction of capital and the reality of what capital's demands did to human bodies. He sold Carnegie Steel to J.P. Morgan in 1901 for $480 million, becoming at that moment the wealthiest private individual in the world. The men who had built that wealth, who had fed its furnaces, poured its heats, and died in its bays, received nothing from the transaction. Several hundred of them were dead. Thousands more were disabled. And the system that had produced both the wealth and the deaths continued operating under its new ownership, U.S. Steel, with the same logic and the same tolerance for human cost that Carnegie had established and Frick had enforced. The Homestead Works operated for nearly a century after the battle on the riverbank. It survived the consolidation of Carnegie Steel into U.S. Steel, survived 2 world wars during which its armor plate and structural steel were consumed by a global conflict at a rate that would have astonished even Carnegie's production engineers, survived the long middle decades of the 20th century when American steel dominated world markets and the men of Homestead, finally unionized again after the Wagner Act of 1935 gave organized labor the federal protection it had lacked in 1892, achieved something resembling the economic dignity their predecessors had fought and died for. The mill closed in 1986. The closure was not dramatic in the way the Battle of 1892 had been dramatic. There was no single confrontation, no barges on the river, no militia on the hillside. There was the slow, structural collapse of American integrated steel production under the pressure of foreign competition, the declining demand for the grades of steel that Homestead produced, and the accumulated legacy of a century's worth of deferred investment in facilities that newer mills in other countries had rendered economically obsolete. The men who worked at Homestead in the 1970s and early 1980s saw it coming in the way that experienced mill men had always seen things coming, in the quality of silence that equipment makes before it fails. By the time the last heat was tapped at Homestead, more than 3,000 workers had been killed at the mill over the course of its operational life, according to the most comprehensive accounting that historians of the site have been able to construct from the fragmentary records available. This figure is almost certainly an undercount. It includes only deaths directly attributable to workplace accidents in a period and a record-keeping system that systematically undercounted occupational mortality. The men who died of lung disease in their 50s, whose death certificates recorded pneumonia or tuberculosis rather than occupational silicosis. The men whose cardiovascular systems failed a decade after retirement from the cumulative effects of heat stress that contemporary medicine did not know how to attribute to industrial exposure. These men are not in the tally. They are in the river. What remains of the Homestead Works today is almost nothing. A shopping center occupying a portion of the original site. A preserved smokestack standing in isolation against the Pennsylvania sky like a monument that does not know what it is commemorating. And the pump house, the structure from which the mill's water supply was managed, and which happened to be the site of the Pinkerton landing in 1892. The pump house has been designated a historic site. It is maintained. People visit it. The distance between what happened at Homestead and the present moment is not as great as the demolished furnace buildings and the shopping center facades suggest. The questions that Homestead raises about the relationship between industrial production and human life, about the price that economic systems are willing to extract from the bodies of working people, about the mechanisms by which that price is normalized and made invisible. These questions have not been answered. They have been deferred in different forms, to different industries, to different countries, to different men and women whose names are not yet in any historical record because the record has not yet been written. The labor protections that were won in the decades following Homestead, the 8-hour day, the workers' compensation system, the occupational safety regulations that emerged from a century of advocacy, investigation, and legislative struggle. These protections are real. They represent genuine progress, won at genuine cost by people who understood that the cost of inaction was measured in human lives. But they are not permanent achievements immune to the same economic logic that built Fort Frick and locked the workers of Homestead out of the mill they had built with their bodies. They are contested achievements, held against the continuous pressure of a system that still, in its fundamental architecture, weighs the cost of a human life against the cost of the measures required to protect it. Crystal Eastman, whose 1910 survey of Allegheny County's industrial dead remains one of the most important documents in the history of American occupational safety, concluded her study with an observation that has not aged. She wrote that the prevention of work accidents was not a technical problem awaiting a technical solution. It was a question of whose interests the industrial system was organized to serve, and whether those interests included the survival of the men the system consumed. Homestead's answer to that question, across the decades of its operation, was consistent and unambiguous. The system served the production of steel and the accumulation of capital. The men served the system. And when the men were used, when their lungs were scarred and their reaction times were slowed and their bodies had given what the system required, the system found other men. The Monongahela River still moves south of where the mill stood. It carries the same sediment, the same cold current from the mountains to the east, the same indifference to the human events that have occurred on its banks. In the 1890s, it carried the rust-colored runoff from the coke yards and the chemical discharge from the furnace operations, a visible record of the mill's presence written in the water's color. That color is gone now. The river has cleaned itself, the way rivers do when the thing that was poisoning them stops. But the river does not forget. The river carries what it carries. And what it carries, if you know how to read moving water, is the weight of every heat that was poured, every shift that was worked, every man who walked through the gate on 8th Avenue and did not walk back out. The weight of the specific, documented, economically sanctioned decision to treat human life as a production input rather than as the thing the production was supposed to serve. They died because the system required their deaths. Not as tragedy, not as accident, as the predictable, measurable, acceptable consequence of a calculation that placed the price of a man's survival below the price of a ton of steel. The river moves. The question remains.